Sir.
Uh, Today, my dear students, we want to study about the uh, effect of or influence of functional group in monosubstituted benzene. So we have seen some of the benzene and its derivative. You can see this is what it is known as benzene. This benzene undergoes the various kinds of the substitution reaction. We have seen that there are various kinds of substitution reaction that this benzene undergoes, and these various types of substitution reactions are generally the nitration, sulfonation, halogenation, Friedel-Crafts alkylation, and acylation. That is what we have studied already. Now, what happens if there is an attack of electrophile? We get electrophile bonded to the benzene ring. This is what it generally happens. Now, when we have the substituted benzene, we may have two type of substituted benzene. For example, if we have the benzene which is substituted by the OH, here you can see that oxygen of phenol has got lone pair. Same way, my dear students, we may have the benzene that has got nitrogen, which is again bonded with the oxygen. So these two type of compounds that we have, that this is what we call it as a nitrobenzene. Now what happens, dear student, that when this kind of two type of substances or two type of derivatives of benzene are available, let us see what happens. Suppose we have a benzene that has got OH group available on it, which has got two lone pair of electron available with it. Now what happens, my dear students, that this electron of this lone pair, they move in this direction, and thus the electron of the double bond also move in a particular manner. And due to that, let us see what happens. Due to this, my dear students, we get the another kind of resonance structure that has negative charge here. These double bonds are available over here. This carbon and oxygen double bond takes place. And here we can have some positive charge here. Now this negative charge actually moves. Let us see how does it moves. So let us try to see how this electron undergoes the resonance. Let us study it well. Now what happens, my dear student, that this double bond, electron of double bond goes on this carbon, and this electron which are available, they come here. So we'll have double bond here, and here we'll have the negative charge. Same way, my dear students, in the next what happens, that this electron or this electron which are available over here, they move in this direction, and this is how the electron of double bond moves on the carbon. So we can see that there is a movement of double bond as well as the electrons. Now in this structure, my dear students, what happens, that the electron of this double bond again get back to the oxygen, and this electron which are available for negative charge, they go on carbon. And finally, my dear students, we may have the structure, this that the positive charge from oxygen is being removed. Now oxygen again got its two lone pair. The double bond between carbon and oxygen are also being removed, and then we have this. Then again, my dear students, when the movement of double bond takes place in this manner, we can get the original structure. So here you can see that we get 1, 2, 3, 4 and 5 various resonance structures. Now what you can see here in this case of phenol, these are all known as the resonance structures of phenol. In case of phenol, my dear students, there is a negative charge on all the resonance structures. This negative charge, what you can see here, it makes the attack of electrophile easy. So this is what here what happens, that this makes the attack of electrophile easy, and those groups, please remember dear students, that those group that involves their electron in resonance inside the benzene ring generate negative charge on carbon. As they generate the negative charge on carbon, my dear students, they actually, such groups activates benzene ring. Now for what do they activate? That is the question arises, that for what purpose do they activate? Such groups activate the benzene ring. They activate the benzene ring for further electrophilic substitution. So here what happens, this phenol or the hydroxy group available on benzene actually activates the benzene ring for the further electrophilic substitution reaction, and this is how we can have the more substitution reaction that takes place, and we can, or benzene or such phenol is more prone to undergo the electrophilic substitution reactions. One more thing I would like to bring it to your notice, my dear students. On the first position, there is already a hydroxyl group present. But if you look into the negative charge, the negative charge comes on second position, it comes on fourth position, and it goes on sixth position. So now let us see what happens. We have seen that during the resonance structures, my dear students, into the benzene, the first group is already present or having OH. The negative charge comes on the first position, it comes on the fourth position, and it goes on the fifth position. So you know, not first position, second position, my dear students, I am sorry, it's a second position. So you know, 1, 2, 1, 4 and 1, 5 kind of. So electrophile can easily attack, which is positively charged, on second position, on fourth position, and on sixth position. Not even 5, my dear students, that is the sixth position. Once again, let me explain it once again to you. We have seen that into the benzene ring, if we have OH group bonded to it, and if this position we call it the first position, then this is second, third, fourth, fifth and sixth position that we have. And we can see that the negative charge is generated on the second position, on the fourth position, as well as on the sixth position. So suppose if E plus attacks, it is definitely going to attack on the position where there is a negative charge. So the new electrophile that is going to attack on this phenol should attack on the, apart from one, there is one, something is already available on second position, it can attack on fourth position, it can attack on sixth position. But we are very well aware, my dear students, that these various positions are given the names. Like 1-2 position is known as ortho position, 1-4 position is known as para position, and 1-6 position is again known as the ortho position. That means if something attacks on phenol, it will be bonded to the second position, fourth position or sixth position, and thus the product that we get by the electrophilic substitution reaction of phenol is going to be either ortho product, or my dear students, or we will have para product. Remember that we will not get meta product. Because there is no charge available, negative charge available on third and fifth position to attract the electrophile. No charge available, no charge available to attract the, there is no charge available to attract the electrophile, that is your E plus. So this is how we can understand about the attack on the ortho as well as the para position. Now let us try to understand this in a detail, my dear students. So there are few groups like OH. There are few groups like OH or hydroxyl, or my dear students, we may have NH2, or my dear students, we may have NHR, or my dear students, we may have NHCOCH3, or my dear students, we may have OCH3, or my dear students, we may have CH3, or my dear students, we may have C2H5. These all groups, what you can see here, these all groups activate benzene ring for, these all groups activate benzene ring for the electrophilic substitution. This is the first thing. Second thing what we can understand here is, these all group are ortho-para directive. What does it mean? It simply means that the it simply means that the new added electrophile the new added electrophile should be added to second, fourth or sixth position. So please learn this groups, my dear students, which are ortho-para directing, or they are the activating groups. Please remember, my dear students, they activate, and that is why they are known as the activating groups. They are also called the ortho-para directing groups. This is how, my dear students, we understand about the various kinds of groups. Now we want to study about those groups which are deactivating groups. So let us study about the deactivating groups. Deactivating groups, or my dear students, they are the meta-directing groups. Let us study about them. Let us study, or let us take the example of our own nitrobenzene. Here, my dear students, there is a N double bond O present on here, and there are the electrons available on this oxygen. So let us study about the various electrons that are available on the oxygen. Now what happens due to a certain reason, this electron from nitrogen, they goes on the oxygen. As oxygen is more electronegative than nitrogen, the electron of double bond goes on oxygen. As the electron of double bond goes on oxygen, the electron of double bond present in benzene also go between carbon and nitrogen, and we get a carbon-nitrogen double bond form. So this is how we can easily understand, my dear students, that here we have the various types of so now we can see that there will be a double bond here. Now as you can see that this carbon has lost its electron, and that is why it has got the positive charge on it. Then you have nitrogen, there is a double bond produced. This has got 6 electron and it possesses negative charge on it. And then we have oxygen over here. And of course, there are double bond present in this manner. Now we have the next one to go with. Here we can see that there is a movement of electron we can observe. These electrons generally move and they go to the this electron, as this carbon has got positive charge, they move in this direction, and the positive charge is changed. Now in this case, the positive charge is generated on this carbon, and we have the double bond present on it. So you can have this double bond, then we have again double bond here, then we have nitrogen, we have oxygen which are bonded on it. So this is how we can have the negative charge produced on oxygen. Then, my dear students, we can show some more movements of electron as well as. Now what happens, this electron, they move in this direction, and thus finally we get the next move, my dear students. So as we can see this next move, we can easily see that this will give us the next product. There will be a double bond over here. There are already double bonds. The positive charge goes on the sixth carbon. There is a double bond present. This double bond is between the carbon and nitrogen, and we can see that there are negative charge on oxygen. Now what happens, dear students, the double bond electron, they come back to the benzene ring again. So as this electron from the double bond, they come back to the benzene, we may have the next kind of structures. And in this structure, my dear student, we will have the double bond present over here, here and here. This carbon nitrogen single bond takes place. The oxygen from the electron from oxygen, they come back to the double bond between nitrogen and oxygen. And as this double bond is created over here, we can have this kind of nitrobenzene. And this nitrobenzene is turned out into the initial structures by the movement of double bond electron in a very nice manner. So this is how you can see that there is a positive charge generated on the various carbons of benzene ring. Here you can see that positive charge is generated on the various carbons of the benzene ring. Positive charge generated on various kinds of benzene ring. As this positive charge is generated on the various carbons of benzene ring, sorry my dear students, I made a little mistake, various carbons of benzene ring. So this positive charge is generated on the various carbons of benzene ring. As there are various carbons, as this positive charge is generated on the various carbons of the benzene ring, my dear students, various carbons of the benzene ring, the electrophilic attack become difficult. The electrophilic attack in this case become little difficult because electrophile is positive charged, because electrophile E plus has also got positive charge. So we can see that there is a positive charge generated on the various positions here. What are those various positions where the positive charge generated? If we call this as a first position, then on the second position, then on the fourth position, then on the sixth position. But my dear students, there is no positive charge on fifth and third position. There is no positive charge on fifth and third position. So what we can easily understand in this case is, if electrophile attacks if electrophile attacks, it is joined to third carbon or fifth carbon. As this electrophile is joined to the third carbon or the fifth carbon, what we can simply understand here is that here we have both this third position and fifth position, 1, 3 or 1, 5 are the meta positions. And you can see here that on 1, 3 or 1, 5 carbon, if the new electrophile is attached to the fifth carbon and third carbon, this group, like nitro group, they are meta directing group. So this is how we can understand, my dear students, that those groups which are deactivating groups, they are generally the meta directing group. So now let us see the deactivating groups. Or my dear students, we can call them as a meta directing group. So which are those deactivating groups or meta directing group? Let us look at them. There are various groups which are meta directing group or deactivating group. They are generally the nitro group. Then my dear students, we have C triple bond and cyanide group. Then my dear students, we have aldehyde group. Then my dear students, we have carbonyl or C double bond OR group. Or my dear students, we may have this carboxylic acid group. Or my dear students, we may have ester group. Or my dear students, we may have SO3H. So these all are the group. They are the deactivating groups as well as the meta directing groups. So this is how, my dear students, we can easily understand about the meta directing group as well as the deactivating group. Just for your information, my dear students, let me tell you that if there is CCl4 bonded to the benzene ring, it is also meta directing in nature. This is just an extra information that I would like to share with you. Now let me solve some of the, let me take you to the next question, that is about the combustion of benzene. Let us study about the combustion of benzene, my dear students. We have seen that benzene is a hydrocarbon, and whenever there is a hydrocarbon burns, it reacts with oxygen and it produces carbon dioxide and water vapor as well as heat. Now look at the number of carbon. If you look at, there are 6 carbon, so it is going to produce 6 carbon dioxide. There are 6 hydrogen, so it is going to produce 3 water molecules. Now let us calculate the number of oxygen. 6 2s are 12 plus 3 15. So we can write 15 by 2 O2. And this is how we can write the combustion for any compound. So this is the combustion for benzene, my dear students. Now in your exercise, there are few other questions given for what you need to write out the reaction for a combustion. So let us see the various compounds when they undergo the combustion. Next one is our butane. You know, butane is an alkane and it has got 4 carbon. So CnH2n plus 2, that is 4 2s are 8 plus 2, that is 10. So it's a C4H10. So we can easily write C4H10. Then my dear students, we write O2, and then we can see that 4 carbon will give 4 CO2 and 10 hydrogen will give 5H2O. Now we can calculate the number of oxygen. 4 2s are 8 plus 5, 13. So we can write 13 by 2 O2. The next question that we have, that is about the combustion of pentene. Pentene. Pentene is an alkyne which has got the formula CnH2n, that is C5H10. So again we can write it this way. We have C5H10 that undergoes the combustion and we get 5CO2, and then again we have H10, so we can write 5H2O. So total number of oxygen 5 2s are 10 plus 5 15, so we can write here 15 by 2. The next question, my dear student, is about the toluene. The next question, my dear student, is about the combustion of toluene. So let us think about toluene. Your toluene is nothing but C6H5CH3, which you can easily write it as a C7H8. So let us go for it. We have C7H8, 5 plus 3 8, and 6 plus 1 7. It undergoes the combustion. We are going to get 7 CO2, my dear students, and we will have 4 H2O. So 7 to the 14 plus 4, 18. 7 to the 14 plus 4, 18. 18 by 2, that is 9. So we will write here 9O2 simply. Same way, my dear students, we have the next question, that is about the hexane. Please remember, hexane is an alkyne, my dear student. And when this alkyne we write CnH2n minus 2. Hex represents 6. So we will have C6H, 2 6 are 12 minus 2, that is 10. So we can write C6H10. And then, my dear students, we have O2. That gives us 6 CO2, my dear students. This 6 CO2, and then we can get H10. So we will write 5 H2O. Now 6 to are 12 plus 5, 17O. So we will write 17 by 2O. So this is how, my dear students, we can easily write the combustion reactions for many compounds. Now here, my dear students, I would like to share one very important question, which is known as the conversion. So here we want to study about how will you convert ethanoic acid into the benzene. The question here we want to study about is, this is the most important question, how will you convert ethanoic acid into benzene? How will you convert ethanoic acid into benzene? So that is what, my dear students, we want to study about. How will you convert ethanoic acid into benzene? We want to convert ethanoic acid into benzene. For that, we'll write the various steps, and we will use almost all the knowledge that we have gained about the alkanes, alkenes, and alkynes and benzene. So we will start with the CH3COOH. This is your ethanoic acid. This ethanoic acid, my dear students, when undergoes the reaction with NaOH and CaO, we know that it's 3:1. Here the reaction that takes place is known as the decarboxylation reaction. This is what it is known as the soda lime. And my dear students, we will get here methane produced. Now this methane, whatever, let me do some improvement, my dear students. We want to convert ethanoic acid to benzene. So first we need to take ethanoic acid and we need to allow it to react with sodium hydroxide. Water molecule is being removed, and then we can get the sodium salt of ethanoic acid. This sodium salt of ethanoic acid, when undergoes the reaction with NaOH and CaO, that is soda lime, Due to that, my dear students, the decarboxylation takes place. And due to decarboxylation reaction, my dear students, we get methane produced. This methane, when undergoes the reaction with chlorine into the presence of light, it gives us CH3Cl, chloromethane. This chloromethane, if it undergoes the Wood's reaction, please remember Wood's reaction in the presence of sodium, metal and dry ether, it is going to give us CH3, which is known as ethane, my dear student. Now this ethane, when undergoes the chlorination, it gives us the chloroethane, that is C2H5Cl, or we can even write it as a CH3CH2Cl. This CH3CH2Cl, if it is allowed to react with alcoholic KOH, elimination takes place. And due to elimination, my dear student, here we will get ethene, CH2 double bond CH2. This is what it is, ethene. Now, my dear students, this ethene undergoes the reaction with Br2 in CCl4, and that gives us the 1,2-dibromoethane. This 1,2-dibromoethane, my dear students, when it undergoes the reaction with the alcoholic KOH, there will be again elimination of HBr, and we will have CH2 double bond CHBr. This CH2 double bond CHBr, when it reacts with sodamide, my dear students, there will be again elimination, and we will get CH triple bond CH. These three molecules of CH triple bond CH, when they undergoes when they are passed through the red hot iron tube, when they are passed through the red hot iron tube at 873 Kelvin, they gives us benzene. So my dear students, I would like you to learn this. This is the most IMP question. It is almost, almost all your topic have been revised into it. And please learn this conversion for the next exam. This is the most IMP question I would like to suggest you. Please learn this.